actually, this is a good minimum wage for this town. Most places are like $7.
Yeah, I think that like federal was just
Federal is $7.25.
I gotta look my Are we kidding? Okay, wait.
That's so good.
Wait, how is that possible? Because I know I cannot go all of you.
Wait, that's so good.
I bet it's because you know, like the herb, like. Usually there's like 2 questions that you get as freebies. So I bet that's what, like I got. But then like.
That's so good.
Because I looked at my grades earlier and I was like, I always look and I say go down. Because like I just started reading grades about my grades.
It's just a
I like it.
So I didn't know they could go
I can use a lawyer.
It's so good. It's so good. I mean, I did fine. Was that 100? Yeah, I mean, it's okay. It's so good though. That's a good way to start off.
Right? That's good. I know my work is going to get harder. So like it's going to
We just turned up.
Yeah, it is.
Good job. So I have short memory.
I love watching your dance videos. I literally like, yeah. I'll like watch it to the end and then I'll go back and watch it again and I'll watch it again. I'm just like, how is she doing this? It's just so sweet. There was one part where you like, like a back bend type thing, but without ever like touching the ground. I don't know how to describe it, but I was like, holy cow, I had to like rewatch it like 4 times to figure out what we're doing. It was so I was just in the hallway and like the meeting go, you're not as dumb, you're wearing a lemon backpack. You know, crazy change.
I don't know.
Okay, Lucas, Melissa, Lucy. Okay, good afternoon, guys. Got a few handouts for you, and as usual, this agenda up here is the first day, so we won't get to most of this today. But we are now diving into Unit 2. Now, I think I had mentioned in here that Unit 1 is, I don't know, maybe not my favorite. I like limits just fine. I mean, I like all math stuff, but limits is very much like every single class. Here's a lot of information, and you got to try to remember it and try to make those connections pretty much as fast as possible so that we can move on. I think I'd mentioned Unit 2 is not so much like that. There's a lot less information, but we use the information more, so we're going to need more practice than we did in Unit 1. That being said, that's not true today. So I've got to give you some skills and some background information so that you know a little bit better about what a derivative is so that we can actually start practicing taking the derivatives. So in this unit, we don't do a lot of real-world applications yet. We get into a little bit, just so you know that they are important, but actually the third unit, we look at some really interesting real-world stuff that you can apply all the time. Also, before I forget, I told you guys on Friday I would stay late to get the rest of your quizzes graded, and I did, and then I forgot to click the publish button, so you couldn't check it all weekend, and that was my fault. I'm sorry. If you've not looked up your test grade yet, do not do it right now. I don't want you to be distracted. Y'all can look it up after class. Okay, but we need to first start off with what the definition of a derivative is. And so after our quiz last week, I kind of explained to you that the definition of a derivative, which is this guy down here, is really just a fancy looking slope formula. But it's the slope formula that has generic points. And try to get the second point as close to the first point as possible. We try to get h to go to 0. So that's where limits are needed, and that's why all calculus classes start with limits. So you have some idea of what that's talking about. So I'm not going to go real in depth on that because we've already previewed that. But some of the gist of it was in Algebra 1, if you had a linear line, you could count rise over run, you could pick 2 points and plug them in the slope formula, or if it's in mx plus b or point slope, you should be able to just see the slope depending on how it's written. The problem in calculus comes when something has a bunch of curvature. So to describe the slope of something with curvature, we just tend to use the word derivative, even though it means the same thing. So if I want to know the derivative here, it's positive, but down here it's probably 0. Over here it's something negative. It's going to change. Your derivative tends to have an x in it because you got to plug in for x to solve. You want to know the derivative at 0, you plug in 0 for x. You want to know the derivative at 2, you plug in 2 for x, etc. So, we talked about a tangent line last time. We're going to talk about a tangent line all semester. But basically a tangent line is a great little visual of a derivative because it helps you see the slope at a particular instant. So m is what you should be used to for slope. So this is trying to say the slope of a tangent line is the same thing as f prime of x, which is the same thing as the derivative of the definition of a derivative. So right here, you need to make sure you notice this little asterisk looking mark. That changes what we're talking about. If it's just f of x, we're talking about the function, but if it's f prime of x, we're talking about his derivative. They measure two different things. A function is great for finding a bunch of points. A derivative is great for finding a bunch of slopes. They just measure different things. And before the semester is over, we will talk about the second derivative and what it's used for as well. It also has some real-world applications. And in fact, the third derivative does too, probably the fourth derivative even, but third and fourth applications don't show up in AP. So when we get to the next handout, I'm going to show you something called power rule. So for now, just trust me, this is how you do the derivative. But with questions 3, 4, and 5, I want you to see that it's all basically the same word, but depending on what the directions asked for is going to change what our answer looks for. So if you're asked for the derivative, you're going to take the derivative. So if the function is y, the derivative is y prime. Without that prime mark there, it is incorrect. And again, until we go over the next handout, you just have to trust me that's the derivative. Sometimes that's all you ask for. Can you find and take the derivative? That's the bulk of what Unit 2 is about. Again, right now you're just having to trust me. But the derivative is basically a slope formula for any value of x. If I want to know the slope at 0, I would plug in 0. And I know the slope, or the instantaneous rate of change, same thing, at that x value. If I want to know what's the instantaneous rate of change when x is 100, I would just plug in 100. Doesn't matter. So that's what question 2 is talking about. If it just asks you for the slope of the tangent line at x equals 1, you would not only need the derivative like question 3, but you would actually need to plug 1 into it and solve. Now understand what that's saying. It's saying at x equals 1, at that exact instant, it has a slope of -2. So I need the derivative to find the slope of the tangent line, and I need the slope of the tangent line, what I just did in question 4, for question 5. Sometimes you're asked for the equation of the tangent line, and I'm going to show you this in the calculator in a second. But anytime we talk about a tangent lines are linear. This guy is linear. And the easiest way for you to write a linear equation is with point slope. I know a lot of you like slope-intercept, but slope-intercept is actually more work and less versatile. You have to dig in and do some thought into thinking about what the y-intercept is. Whereas point slope, which is what I tend to use, you need the slope. So if I want the slope at -1, I would plug that into the derivative and get -2. That's what I did in question 4. And then the only other difference with this is I need to make it a whole equation. So if we're trying to do this at x equals 1, I'm going to plug in 1 for x1. How do I solve or find y1?
Plug 1 into the original function.
Exactly. If you want a point, you plug into the function like you've always done. If you want a slope, you plug into the derivative like we did in question 4. That's important to make that distinction. So if I plug x equals 1 into the function up here, 1 minus 4 plus 3 is 0. So again, I answered 3 questions with basically the same word. Sometimes you're just asked to take the derivative, which you'll understand better after the next handout. For now, I'm asking you to trust me. Sometimes you're asked for the slope of the tangent line, which just really means what's the slope at that value. So you plug in the x value into that derivative. And sometimes you're asked to go a little bit further into equation of the tangent line, and you would make the tangent line. The slope comes from what we did in part 3, and the point comes from plugging x into the function as usual. I'm just trying to emphasize that depending on the directions, your answer could look very different. Your answer could be this, or this, or this, just depending on the directions, even though it's all talking about the same function at the same value. So, now, to really try to hit home, since we are going to be doing derivative stuff, all semester, I want to show you this very quickly on a calculator, and you don't have to put it in the calculator also. I'll put it up on the screen for everyone to see. Okay, so these last 3 questions were about the equation x squared minus 4x plus 3. So if I have my calculator graph it to give us a visual, it looks like this. And we just did a bunch of stuff. Well, we found the derivative, or I told you the derivative on the first question. We found the slope at x equals 1. So here at x equals 1, do you see at that instant it looks like it's negative something? Well, then we get a negative answer for the derivative at x equals 1. In fact, you could kind of sketch this line, and you could kind of try to do rise over run if you wanted to. It would be very close to -2 or whatever we got. But then in the third part, we are trying to actually graph this tangent line. So we're trying to graph the line that touches this one time, and it touches it only at x equals 1. So I'm going to graph that as well. And it was y minus 0 equals -2 times x minus 1. Is that right? I'm going off memory, so that's right? Okay. So what we found was to make a tangent line at x equals 1, we figured out what the slope needs to be from the derivative, and when I pieced that together into an equation, we're actually drawing that. So you can see how the red line is a tangent line. So when we're talking about tangent lines, that's what we're talking about. Again, it's just a great little visual. If you care about x equals 1 and what's going on at x equals 1, it kind of gives you a visual of what's happening at that instant. Okay. Now, the good news, bad news. So, good news is you don't have to take a derivative by the definition for your AP exam. I had to do that in calculus college, every single test, at least Cal 1 for sure. We are going to learn a bunch of shortcuts and a handful of derivatives that we use so much that we're going to just memorize. That's the focus of the next worksheet. But before we get to that, I need you to know how you are on the hook, because this is how the AP exam does to us. So even though you don't have to use the definition to find a derivative, and it's really not that hard. Those of you that did pre-cal last year, does the name quotient rule, or not quotient rule, difference quotient, does that sound familiar? No? Nobody did difference quotient? Okay. Well, yeah, that's because you had me for pre-cal, so. I'm gonna have to talk to Miss Thomas, I guess. Okay, if you practice the difference quotient, you actually did all of this. You did all the algebra part. If you plugged in 0 for h into those answers, you actually found a derivative by the definition. It's 99% algebra. But for us, they expect us to memorize this definition. This is considered the standard definition. This is the one I derived for you last class. And there's an alternate version. Notice this is basically slope formula as well. Y minus y over x minus x. So this is the alternate. So you have to memorize these, not today, not before next class or anything like that, but you've got to memorize these well enough that you can do process of elimination and narrow down to enough choices. So I've got 4 multiple choice questions on here for you to see what it's like on the AP exam. So again, I don't think you're going to feel super comfortable with these after 4. We're going to practice these again later on, but it at least shows you that what you are on the hook for as far as the definition is concerned. So look at this question. I'm going to do the first 2 for you, and I'm going to ask you to try the next 2 just to see if you can catch on to some or most of it. Okay, when I look at this, this is either the standard definition or the alternative definition. So look at the top of your page. Does this look more like standard or alternate? Okay, so alternate, I would recommend that until you're so good at this you can do this in your head, you copy down the alternate form right next to it, because 1, that's going to force you to write it down and you're going to memorize it over time that way, and 2, it helps you see what you're trying to do, what you're trying to piece together. If this is the alternate form says right here is supposed to be your function. So what is our function in this question? Good, they're in the same spot, natural log of x. And just with that little bit of information, you should already know it's not choice A because they have a different function, and it's not choice D because they have a different function. The function's right here, the function is natural log of x. It's got to be B or C. Now, the next part I just kind of have to tell you the first time, but notice A is here, and A is here, and A is getting plugged into here. So this is f of A. So if I plugged E into the function, the natural log of E is 1. So that's why they put a 1 there. But A is what value you want the derivative of. This is like the derivative at A. So if A is E, I want this one. I want to find the derivative at E. We're not finding the derivative at 1. So I've narrowed it down to 1 choice, circle it, and move on. Yeah. No, it's not. It's natural log of x divided by x. Sure, if there was a divided by x here, then it would be fine, I guess. But yep, that is not the same thing. Okay, let's do 1 more. And I'll let you give it a shot. Again, I'm going to have you practice this. The only way that you're ever going to feel comfortable with these is forcing yourself to practice 5 or 10 of them. So we'll do a Khan Academy on these eventually. But you look at this. Does this look more like the standard definition at the top of your page or the alternate version underneath it? Okay, so this is the standard. And over time, you will eventually memorize that the standard definition is the limit as h approaches 0 of f of x plus h minus f of x all over h. And it gives us something to compare to. So some stuff's not helpful. Some stuff is just supposed to be there, but it helps us narrow down our focus. So notice there's supposed to be the limit as h approaches 0. I've got that. It's supposed to be there. It doesn't help me narrow down my choices. All of this is supposed to be divided by h, divided by h. All of them have that. That doesn't help me narrow down my choices. But now this gives me some hint about what f of x plus h is, and this gives me some hints about f of x. Now, what can be kind of misleading here is f of x is not 3. Sometimes they plug in for x and sometimes they don't plug in for x. They can do it either way. They just have to be consistent. So this is actually the function at some value. Okay, now second period struggled with this, but if this highlighted is f of x plus h, and this that's highlighted is f of x plus h, what would you guess? We'll see if anyone can get it here. What would you guess the function to be? What are they plugging x plus h into? Not f of 3.
Square root x.
It's the square root of x. Very good. Now, they're using a number for x, but instead of x plus h, where there was an x, they're plugging in x plus h, 9 plus h, and they just happen to be plugging in 9 for x. So, notice f of 9, if I plug that in for x, would be what? 3. And that's why there's a 3 there in this question. This is supposed to be f of x. They plugged in a 9 for x here, so they must have plugged in a 9 for x here. So the function has to be f of x, and honestly, that's all you needed. There's only one choice that even had f of x as the function. The other 3 had other functions. But again, this was the hardest part here. So this, you might want to add to your notes here, is like the square root of x plus h, and if you're plugging x plus h into that, then the function must have just been the square root of x. X become x plus h. That's what this notation means. F of x plus h means you plug in x plus h everywhere there's an x. X became x plus h. And then for this particular question, they just happen to plug in a number for x. Sometimes they will, sometimes they won't. Sometimes they'll leave it x, sometimes they'll use a number. But if they use a number over here, they have to use a number over there. They got to be consistent. Okay, so I've only got 2 practice questions for you over to the right. So again, follow the same method. Look at the top of your page, try to figure out if it looks like the standard or alternate version. Write that version next to the question and see if you can figure out what you think the function's supposed to be or where the derivative is supposed to be, and just give yourself the best guess that you can. Commit yourself to an answer, even if it's an educated guess. And I'll give you a minute to do that, or a couple minutes to do that, and then we'll talk about those and then continue on. 7, 7, 7. Yeah, I understand. cut you off, finished or not, because again, this isn't really the focus today. I'm just kind of showing you the introduction. Now, I think the first one of these two is a little bit easier because you had to look at the answer choices to figure out that they were trying to match this to the alternate version, so the second version up there. So it says the derivative would be equal to the limit as x approaches a of f of x minus f of a all over x minus a. So if you figured out which form it was and you put any thought into the function supposed to be in the top left, if the function is cosine of x, that's not true for choice A and it's not true for choice C. Only choice B and D have the correct function there. So I'm not doing any special tricks. I'm just matching that up, and I'm already down to 50-50 in about 10 seconds. Now, A is what you were trying to find, the x value you're trying to find the derivative of. So this is supposed to be a pi, this is supposed to be a pi, and this is f of pi. So sometimes they might write it that way. They might say cosine of pi. What could they put in place of cosine of pi though? Right, because sometimes they're going to change it to a number, like the square root of 9 question, they just changed it to a 3. Sometimes they would make it say -1, sometimes they're going to just leave it cosine of pi. So, not this guy, that's not cosine of pi, it's just pi. This is cosine of pi. D is the only one where all that stuff is true. Note, everything has to be consistent. So, for these, they're always multiple choice. You can just knock off the most obviously wrong ones and then stick with it until you're sure which one is correct. Alright, the second one is a little bit harder because they did not leave x for x, they actually plugged it in. And then sometimes they're consistent, sometimes they're not consistent, but they have to be consistent. So you had to think of that to get this one. But when I look at all these answer choices, they look like the standard definition to me, is this. And again, maybe in a few months, if you keep practicing these, you can visualize it in your head, but for now I would write it down. And so I think these answers are the standard definition, but notice it's supposed to be the limit as h approaches 0. They all have that, so that doesn't narrow down anything. They're all supposed to be divided by h. They all have that, so that doesn't narrow down anything. This is supposed to be f of x, but remember, they might leave x there and they might plug in an x. So this could either be e to the x, which none of these are, so they obviously didn't do that. Or it could be e to the x with this x value plugged into it. Right here, I want to know the derivative at e, so e is what I would be plugging in for x. So this guy becomes the function with e plugged in for x, so e to the e, not a or d from that. And then this has to be the function's e to the x, but everywhere there's an x you replace with x plus h. So this would be e to the x plus h. Then y is the answer, not c. Yeah.
They have to be consistent if they're plugging in the value.
Right, so right here they plugged in e for x, and then right here they didn't plug in e for x. You don't get to just pick and choose. You can either put e in for both, like choice B, or you could leave them both x, and then that would be okay. But you have to be consistent. You can't just plug in some values of x and not all values of x. So you should be aiming for B there. Again, these aren't too bad, but they do just take a little bit of practice before you feel comfortable with them. This is just an introduction, so don't lose any sleep. Don't worry about studying any of that at this point. But at some point you will need to memorize those two definitions to be able to do those. Alright, last part of this handout is we need to talk a little bit more about a derivative and when it exists and what it means and how does it connect to continuity and stuff like that. And then we can get into some of the basic shortcut rules, and we don't have to deal with the definition so much. Okay, so if a function does not exist at x equals 4, then it does not have a slope there. Can't have a slope there if it doesn't even exist there. And then something like x equals 6, if I ask you what's the slope there, I don't know. Some of you might be tempted to say this, some might be tempted to say this, but exactly at x equals 6 only, it also doesn't exist. It's not what it's doing on the left or the right, it's what it's doing at that instant, which doesn't make sense. But what does x equals 4 and x equals 6, what do both those points have in common? They're both discontinuous, right? Discontinuous. So, now that we're starting to talk about derivatives, differentiability just means something has a derivative. If something is differentiable, it's possible to take its derivative. So, number 14, if something is differentiable, that implies that it's continuous. But just because something is continuous doesn't mean it's differentiable. So there are times where you have FRQ questions where you can't do something if it's not continuous. The question might tell you it's differentiable, and they may not tell you that it's continuous. Mathematically, if something is differentiable, it is automatically continuous. So on FRQs, I would write that down right away, because if you didn't need it, it didn't hurt you, and if you did need it, sometimes there's a point or two locked behind that. So that's what I tried to show you above. If it's not continuous, it's not differentiable. To be differentiable, it has to be continuous. To be continuous, it doesn't have to be differentiable. Okay, so for a function to be differentiable, I'll tell you the things that would mess it up. One is it must be continuous, which should mean something to you now. Continuous implies that the limit from the left is the same as the limit from the right. It means that there has to be a point at that x value, and the point better equal the limit. I'm saying those quickly because hopefully you knew those for your last quiz anyway. If it's differentiable, it's continuous, and if it's continuous, by default, we know those three things are true. Also, for it to be continuous, the slope must exist. And I'm going to draw a line for down here in a second. Derivative is like a more advanced slope, but if it doesn't have a slope, it doesn't have a derivative. Okay, and then the last thing is it no sharp turns. In math, we call that cusp. You can't take the derivative at a cusp. So that was up here at like x equals 8 in the picture. X equals 8 is continuous, but because of this sharp turn, your slope can't go from negative something to positive something at an instant. Slope can't change that quickly. So if you have a cusp like this, you can't take the derivative. The derivative there would be undefined, even though the function exists, even though the function is continuous. If it's continuous, if it's differentiable, it's continuous, but just because it's continuous doesn't mean you can take the derivative. Okay, and then finally, I drew an arrow down here. The slope must exist. Remember, if you have a vertical line, his slope is undefined, and so a derivative wouldn't exist when the slope does not exist, since those are basically the same thing. Vertical lines, undefined slope means no slope means no derivative, because derivative and slope mean the same thing. The sooner you pair up the idea of derivative and slope being basically interchangeable. The quicker you'll grasp onto those things. Okay, trucking along here. Let's move on to number 18. Now, this is the stuff. Again, you're going to learn it with some practice and all that kind of stuff, but this is the stuff that you will use for your entire calculus career. Whether that's, I don't know, next week, if you drop the class, I guess it's probably too late to drop, but whatever. Or through differential equations, Cal 3, advanced calculus, you're going to be using this stuff forever. So these are the basics. So we've got the definition of a derivative. We focused on that on the last handout. So now we're talking about the shortcuts. What are some of the derivatives we use so much that we want to memorize them? And I'm going to introduce you to one rule called the power rule. Are you with me? Okay, so first off, the derivative of a constant. So this is like a verb. It's saying take the derivative of this. Well, let's think about what this graph looks like. What does y equals 6 look like as a graph? My ears are way too old to hear that, but horizontal line. What kind of slope does a horizontal line have? What? So what would its derivative be?
Same as the slope, which is 0.
Same as the slope. Slope and derivative mean the same thing. Right here, the derivative of a constant is always 0 because its slope is always 0. Over to the right, the derivative of -2 would also be 0 because -2 is a constant. Derivative of a constant is always 0 because it doesn't change. It's flat. There's no x, there's no variation, there's no variable. It's always constant. Okay, power rule. I'm sure a few of you already know the power rule. Power rule is super easy to use if something's in the right format. So the format has to be that you've got a number times x to some power, number times x to some power, number times x to some power. It's got to be in that format for us to do the power rule. But this is what your textbook would say. If you're taking the derivative of x to the n, his derivative would be n times x to the n minus 1. So you can phrase it in your head that way if you want to, but most people just say bring the power down. So if the power is n, you bring it down out front. If the power is a 2, you bring it down out front. And then the exponent gets lowered by 1. The exponent goes from n to n minus 1. That's the power rule. Bring the power down, lower the power by 1. Bring the power down, lower the power by 1. What do you think the answer is to the last one? Okay, too slow. 1000 x to the 999. Bring the power down, lower the power by 1. That's the power rule. So I'm going to bug you for just a second, and I'm going to show you. Okay, never mind. We don't have time for that. What I was going to show you is on the other handout that we just finished. If you look at question 3, you can see I did that so quickly because I just was applying the power rule. Okay, there's something called the constant multiple rule. So if you have the same format, but there's a 2 out front, or a 3 out front, or a 1/2 out front, or a 4 out front, that's just going to make it 2 times bigger, or 3 times bigger, or 1/2 times bigger, or 9 times bigger. Whatever is out front is just going to make it that many times bigger. So this is like 2 times the derivative of x squared. This is like 3 times the derivative of x to the 8th. This is like 1/2 times the derivative of x to the 5th. You guys okay where I'm getting these derivatives? Okay. This is 9 times the derivative of x to the 1000th. So that's why it's working. Yes, sir.
Why is it 9 times, not 4 times?
It should be 4 times. I just can't read. Thank you. So that's how it's working. That's not how I tend to say it, though. So it's fine if you didn't copy that down. I'm just going to say it a little bit differently because I think this way works better for you. I honestly just think of these as power rules still. I bring the power down, but if something's already there, multiply them together, then lower the power by 1. Bring the power down, if there's already something there, multiply them together, lower the power by 1. Bring the power down, multiply it by the half that was already there, lower the power by 1. Bring the power down, lower the power by 1. You see how those are equivalent to what I wrote down the first time? I don't usually want to say 2 times 2x, I'm just going to say 4x. I don't want to say 3 times 8x to the 7th, I'm just going to say 24x to the 7th. So to me that's really just a power rule, but it is technically a different math thing. Okay, we also need to be familiar with the sum and difference rules. So let me do just a touch more and then we'll find a stopping place here in a second. So unlike limits, remember when we talked about limits, I don't know, it doesn't matter, but we talked about if you add stuff, you could do the limits separately and then add your 2 answers. Or you could subtract, you could do the limits separately and then you could subtract them. Same with multiply, same with divide. Limits are not the same. I'm sorry, derivatives are not the same. Derivatives work that way for sum and difference, but for multiply and divide, we actually have something called the product rule and quotient rule. We actually have to follow formulas for those, and that will be for Thursday's class. Basically, all this means is if you have multiple terms you want to take the derivative of, just take the terms separately. 4x and 24x to the 7th, and if it says add, slap a plus sign between them. If it says minus, slap a minus sign between them. Okay, so last one and we'll find a stopping place here for today. What is the derivative of 7x? How do I do power rule to this? Just 7, right? Because if you bring the power down, 1 times 7 is 7, and then when you lower the power by 1 it becomes 0, but anything to the 0 power is 1, so you just get that. And honestly that should kind of make sense because this is like mx plus b. The number times x is your slope. Slope means derivative, so same thing. Okay, unfortunately we're just out of time, so tomorrow we will quickly finish these up, the rest of these notes, and then there is a book assignment. Okay, wait. I'm sorry, I forgot to tell you this. These book printout pages, these are not yours to keep. I have 1 class set. Do not write on these, do not keep these. I need these back. So I have a basket up here. Just throw them in the basket. If you guys do keep them or write on them, and then I don't have a class set, the other option is me making you pick up the textbook when we need the textbook. You're still welcome to check out a textbook if you ever change your mind. And last week on Google Classroom, I did share an e-book version. So you don't have to do any of this book assignment. I'm just letting you know why I'm washing my hands of that. But you can actually download the entire book. It's like 50 megabytes or something, but that's in Google Classroom, and so that's also an option when you get there. Okay, no class puzzle today.